So how do we simplify 1/2 times 3/2 squared?
Multiply the fractions in there first.
Yes. So order of operation tells us that we multiply the fractions inside first, then we, well, because it's a grouping, that's grouping symbols. So you do the grouping symbol first, and then you do the exponents. So what would be in what is 1/2 times 3/2?
It's 3/2.
What do we do when we multiply? Yeah, 3/4. So this is 1 times, it's been a hot second. We've been doing the hard stuff. I know, I'm sorry, I can't do anything about it. All right, so it's 1 times 3, 2 times 2. And for some reason, it's harder when the denominators are the same. Like I tend to do the addition subtraction steps and keep the denominator instead of just multiplying like I'm supposed to. I don't know. So anyway, so we have 3/4 squared. So now what do we have? So what do I square? The numerator and the denominator. So this is 3 squared over 4 squared, which is 9/16. All right. Just a little review. We're going to have a lot of fractions in this section. And for the most part, we just keep them fractions. So don't worry about turning them into decimals because Lord have mercy, we don't have time for that. All right, so there's some equations so far we've worked with. They are pretty easy to solve, very easy to solve with linear equations, fairly easy to solve with quadratic equations. However, there are quite a few real life applications that are not easy to solve by either factoring or taking roots. So we've learned how to factor, we've learned how to take roots. So now we're going to learn how to solve by completing the square. So there's really just, I'll make sure that I've highlighted sort of the main formulas that you need to follow. But once you follow the formula, then it should be pretty easy to just plug things in and get them figured out. Okay. So our first example that we have, I'm just going to start right off with sort of a basic one. So if you have a quadratic trinomial and it equals a value. So the main difference here is it doesn't equal 0. So we're not really able to move things around that much. However, you have a square. You have a difference of squares. No. What is it called? Okay, yeah, it is a difference of squares. Here. So we can turn this trinomial into an a squared or an a minus b squared. A plus b. So what times what equals 16? Okay, so we know that 4 times 4 equals 16. Now, can we add 4 plus 4 and get -8?
Not this again. Yes. No.
What do we have to add together? Does that still work if I have -4 times -4? Does that still equal 16? And if I have -4 plus -4, does that give me -8? So this is x minus 4 squared equals 49. So we've put it into, yeah, so it's a binomial squared. A minus b times a minus b. In this case, it's x minus 4. All right, so now we can just solve by taking roots. So our square root property means this becomes what? Remember, we're undoing, we've isolated our squared expression, x minus 4 squared. So now we just undo the squared by taking the square root of both sides. And so what does that give me? X minus 4 equals plus or minus 7. Don't forget that. So now what do we do? Right, we add 4 to both sides. Saw a little bit on the quiz. Can we just now say that this is 7 plus 4 and it's 11? No, how do we write this? X equals 4 plus or minus 7. And then we have the two values for X. X is either 4 plus 7 or X is 4 minus 7. So this gives us 11 and negative 3. Those are our solutions. Nothing too new. We've taken what we've learned earlier in the chapter and what we learned last section, combined them into taking complete squares. Or solving by completing the square, so we've solved it. Yes. Some of them though, so this next thing I'm going to show you looks very complicated, but if you can just follow it, it makes this a lot easier because a lot of times you don't know what that C term, that constant term is. So this is a way to find that without having to, you're creating your squared binomial without having to do a lot of the factoring. Okay, so completing the square. Y'all were the note card kind of people. This would be something great to put on a note card. Okay, to complete the square of an expression. So if you have an expression that is in the form some variable squared plus a constant b times that variable. So this is like our, like if we had x squared minus 8x. Then you add the square of half the coefficient of the linear term. Let me just show you. So for this expression, you have x, you need to complete the trinomial, you have x squared plus bx plus b divided by 2 squared equals your squared sum, your squared binomial, x plus b squared, or b over 2 squared. All right, this right here is what you need to make sure that you've got. So let me show you what all these stand for. All right, every quadratic equation can be changed into an equation in which one side is a perfect, so this creates a perfect square trinomial. So you find that C term by squaring the coefficient of the middle term, b, divided by 2, and that gives you your C. So you create a perfect square trinomial, and then you have a perfect square, or perfect square, yeah. So then you have your squared binomial equals a constant. And then we can do what we did last section where you just use the square root property and find your answer. So let me show you what I'm talking about. Example 2. Oh, not with a highlighter. I've already done the homework assignment, and I promise after you use this multiple times, it is not complicated. It looks extremely confusing. It's not. Just you got to pay attention right now and understand what the parts mean, and you'll be fine. I promise. So we want to complete the square and factor the resulting trinomial for each expression. So the first one is the baby steps. Okay, these are baby steps. We're not solving anything just yet. So this, if we have x squared minus 6x, so we want to complete the square and then factor the resulting trinomial. So we're turning this binomial into a perfect square trinomial. Now, this one is fairly simple because our b term So you have to look at that b term and what plus what equals -6. That's the same number. 3 plus 3, or in this case, so we know that -3 plus -3 equals 6. So I'm going to show you, this is one way, and I'm going to show you using the equation, the formula that they gave us, how that works. But we know that 3 times 3, or 3 plus -3 plus -3 gives us -6, which is our b term. And we need a c term to make this a trinomial. So what's -3 times -3? We're multiplying. So negative times a negative is a positive. But x squared minus 6x plus 9. Can we turn that into, is that a perfect square trinomial? Remember, your first term is squared, your last term is squared. So this is just x minus 3 squared. So we found our c term to create the perfect square trinomial, and then we factored it into its squared binomial. And so then once we start solving, we can then use, like, say it equals 49, right? So we would now be able to solve for x. This is just kind of the first part of it. Now, let's do that using the formula. So we know what our answer is because these are pretty easy numbers. We know that -3 plus -3 is -6, -3 times -3 is 9. So we know what our binomial is, what our factored term is. Let's use their formula. So they're saying if we have x squared plus bx, that gives us our perfect square, which is x plus b divided by 2 squared. So x squared is your variable. It's always a variable. It'll stay that way. That's your a, z, w, whatever they use. What's b in this example? What's our b? -6. So b equals -6. So plug that in. X plus -6 divided by 2 squared. And then can we simplify? What's -6 divided by 2? Do those match? So see how you use the formula to do that? The formula works when you have numbers that don't go into each other nicely, like 3 into 6, or 2 into 6 rather. So we end up leaving them as fractions. Okay, so this is the completing the square. And the way I did it is just regular factoring. It gives you the same thing. All right, so let's look at, let's see, let's look at the second one. Second one shows you what it looks like when you've got fractions. Same process, it just looks a lot more intimidating. So y squared plus 5/3 y, and we need to turn this into a perfect square trinomial. So what's my b term? 5/3. So I'm going to plug that into my completing the square. So this is x squared plus 5/3 x equals x plus, now b is 5/3. So 5/3 divided by 2 is just 5/3 times 1/2. Remember, dividing by one number is multiplying times its reciprocal. So this is x plus 1/2 times 5/3. That's why we did that little review at the beginning. Huh? That's this, right? Dividing by 2 is the same as multiplying times 1/2. So I'm just taking that dividing, because I don't want to do 5/3 divided by 2. That's crazy. So we just we multiply times 1/2. All right, then. All right, so now we just simplify. Okay, and this is squared. So this will give us our perfect square. Keep it inside parentheses. So this is x plus. So what's the second half of my binomial here? It's always the same numerator, and it's always the denominator times 2, like always, because you're multiplying times 1/2. So 5/6 squared, and there's our perfect square. We didn't have to figure out what it was. So when you write this as your trinomial, so this 5/6, this is your C term. So in your perfect square trinomial, it's y squared plus 5/3 y plus 5/6. That's your perfect square trinomial. And it will give you, I used x, sorry. It will give you y plus 5/6. Wait, hold on. It's 5/6 squared. Y plus 5/6 squared. So 25/36. But you can just leave it like that. Okay. Let's look at what it looks like, how this works when we actually solve it. So one thing that you'll notice too in some of the examples, once you figured out what your, like once you've squared your B term, divided it by 2 and squared it and turned it into your C term, you can pretty much just, they ignore the sign, because what is every negative number squared? And every positive number squared, right? So they just ignore it. Sometimes I will keep it in there because that means when you make your perfect square trinomial, if it's negative, when you have your squared binomial, that binomial needs to have subtraction. So I typically will keep it in my example so I don't forget. Okay, so example 3 asks us to solve x squared plus 10x equals 15. Now, if we were factoring, we would subtract 15 from both sides and turn it into the x squared plus 10x minus 15 equals 0. And in this case, you might be able to figure it out. Like what times what would give us negative 10? 15? Yeah, it still wouldn't work out because none of the factors, like there's 15 and 1, and then there's 3 and 5. And none of those, when you add them together, give you plus 10. So you can't easily find your factor, and it's a perfect square trinomial. So we turn the x squared plus 10x into a perfect square trinomial. So I won't write this up, but we'll do it this way. Let's see. So first, we take x squared plus 10x, and we need to figure out what that c term is. So if we use you should be able to look at it. Like what times what, or what plus what equals plus 10? That's the same number. We're looking for perfect square. 5 plus 5. 5 plus 5 is 10. And so that means that our C term here is going to be what? 25. Right. But I'm going to use the formula just so you can see me walking through it. So we know our answer needs to be 25 because that would give us our B term and our C term. And we could factor it to x plus 5 squared. But if I use the x plus b divided by 2 squared, then I have b is 10, and we see that it's x plus 5 squared. And x plus 5 squared means that our last term there is 25. But we don't have to worry about factoring it because we just created already the perfect square trinomial. I keep saying that, the squared binomial. So this is our squared binomial. So now I need to solve it. Where do I take that squared binomial and plug back into my original equation? So I plug that in on the x squared plus 10x side. However, let me show you. Let me show you what you got to do here. Okay, so first we take we change those the x squared plus 10x into a perfect square trinomial. So this is x squared plus 10x, but what did we add to the left side? We added 25, 5 squared, right? We added 25. So what do we have to do on the right side? We have to add 25. So this is like when we, do you remember when we were like had one equation, like a two variable equation minus a 2 variable equation, and we had to make the coefficients opposites? So we just multiplied like everything times. So that's pretty much what we're doing is we're adding 25 to make it a perfect square, a squared binomial. But if you do anything to one side of an equation, you have to do it to the other. So this means, so I'm going to go ahead and turn the x squared plus 10x plus 25 into my perfect square binomial. I'll just keep the notes so you've got them. And then 15 plus 25 is 40. So now can we solve? I know it's warm in here, guys. Try to stay with me. I'm not going to be here tomorrow to help you. All right, so what do I have to do now? Square root of both sides. Yep. So the square root of x plus 5 squared equals the square root of 40. So I know this side is just x plus 5. And do we have a perfect square we can take out of 40? 4 times 10? Probably the only one, because 10 is 2 and 5, so there's nothing else. But so the square root of 4 is what? 2. So we have a plus or minus 2, and then what's left is the 10, square root of 10. And then the last step. We got to subtract 5 for both sides. Can I just add it to that 2 and be done? No. X equals -5 plus or minus 2 square root of 10. And I am not going to figure out what square root of 10 is and estimate my 2 answers. Just leave it like this. If you have an I or if you have a square root, it's not a perfect square, you leave it in this form right here. All right. Another. I know. It takes a lot of room, but yes, you can find something. All of these do help you with the homework problems. So as long as you've got them as a reference, you should be fine. Correct. I think it's Mr. Mullins. All right. Is 3x squared minus 13x minus 10 a perfect square? Is that a perfect square trinomial? Yeah, no, not at all. So we're going to put this in the form that we had previously where the x squared and the x terms are together, and we get that 10 out of the way. So we're just going to add 10 to both sides, and we end up with 3x squared minus 13x equals 10. All right, so I need to find out what my C term is. Oh, one other thing we need to do. Is 3 a perfect square? So let's move it. Well, we divide everything by 3. And that gives us x squared minus 13 over 3x equals 10 over 3. This is definitely one to have in your notes. Okay, so we need to find our C term. So we know that x squared minus 13 over 3x equals x plus 1/2 times negative 13 over 3. There's another parenthesis. That's awful. Squared. All right, so essentially all we need to do is figure out this part right here. What is 1/2 times negative 13 over 3? So it's 1 times negative 13. So I'm going to put the negative in between my x and my constant term. So this is just 13 over 6 squared. Right. Now, in order to know what we are adding to both sides, though, we need to figure out what 13 over 6 squared is. So I know that on the left side, I'm going to have x minus 13 over 6 squared, but this 10 over 3, I'm going to have to add the first main step. Here's the second main step. We have to find what we're adding to both sides. So this is the 13 over 6 squared. So it's 13 squared over 6 squared, which gives us 139. 3 is 9, 3, 106. I haven't had any of let's just check. 9, that's a 3, that's a 3, so it's 169. There we go. That sounds better. 169 over 36. And so I'm adding that right here. All right, so 3 times 12 is 36, 10 times 12 is 120, so 120 over 36 is 169 over 36. You see why we just leave these as fractions. And that is 289 over 36. And so our final equation, ugly though it may be, x minus 13 over 6 squared equals 289 over 36. And so now we solve. So now we use our square root property. So square root of x minus 13 over 6 squared equals, I'm just going to go ahead and split these guys, 289, square root of 289 over the square root of 36. So this third part is we need to simplify the square root of 289 over 36. We know that the square root of 36 puts 6 in the denominator. We need to figure out what is the square root of 289. So 289, no idea. 17, 18, 19. Well, what'd they say? That is just so rude. 17. Okay, so 225 is 15. 16 is 256. So yeah, I would try. Fortunately, they're going to be nice enough to give you a perfect square. 17 times 17. Carry my 4. That's so 9, 8. Yep, it's 17. So 289 equals, so this is plus or minus 17 over 6. Huh? Right. So when we simplify this, these cancel each other out and we're left with x minus 13 over 6 equals plus or minus 17 over 6. That's the nice thing too. You should end up with like common denominators every time, as long as you don't reduce. All right. So we just add 13 over 6 to both sides. And we get x equals, so 7 plus 3 is 10, carry my 1, 30 over plus, oh, no, I can't do that. Hold on. What did I just do? 13 plus or minus 17 divided by 6. So now we can solve it. X equals 13 plus 17, which I just did. Huh? Did you say you want to do this? Yes. All of this we have learned. All of it. We just haven't really put it together like this before. So it's more about understanding what the steps need to be than it is yeah, the math. Okay, so 13 plus 17 is already figured out. It's 30. So x equals 5. 13 minus 17, negative 4 over 6. So that's negative 2/3. Those aren't as bad. And you got the two answers? Sure, absolutely, which you will. Because 13 over 6 plus 17 over 6, you're not adding the denominators. Yeah. 120 over, that was my 10 over 3. I knew because I had this denominator, this was 36, this guy was 36, and I needed to make, I was adding 10/3, this right here, 10/3 plus 169 over 36. So I have to find a common denominator. So I had to multiply both by 12, and that equals 10 times 12 is 120, and 3 times 12 is 36. Nice. Okay, one more. So this one gives an example of doing it with the having an imaginary number in there. Funsies. And then we will have covered everything. Solve 5x squared minus 10x plus 9. The nice thing about these two is you don't have to worry about the coefficient of the x squared and like trying to find what it is. You just create, you're kind of creating your own perfect square trinomial. All right, so first we have to move our constant term. So we subtract that 9 from both sides. That's where the I comes in. 5x squared minus 10x equals negative 9. All right, so I need to figure out what my C term is. Well, but what do I have to do first? Get rid of that 5. All right, so this becomes x squared minus 2x equals negative 9/5. Now, again, x squared minus 2x Should be easy to figure out what your perfect square trinomial is. What plus itself equals -2? -1 plus -1 is -2. So you can do the equation, but it's going to be x minus 1 squared equals. But we added, in order to get that, we added 1. So that's why it kind of helps to go ahead and do your whole trinomial. Let me do that real quick. So that's x squared minus 2x plus 1 equals -9/5 plus 1. And I'm going to write that as 9/9. All right, so our perfect square trinomial becomes x minus 1 squared and negative. Nope, I'm an idiot. Hold on. I mean, I'm not, but brain dead. -9 plus 5. This gives us -4/5. Yeah. All right, so now step 2. Square root of x minus 1 squared. So that cancels that out. And the square root of -4/5. So I know this guy is going to give me x minus 1. The -4/5. I'm going to go ahead and pull up my I. And square root of 4 over square root of 5. So I know the square root of 4 is what? 2. So we're going to be turning that into a 2. So don't have to multiply it times this, but we got to get rid of that square root in the denominator. So we multiply times square root of 5 over square root of 5. And so we end up with plus or minus 2i square root of 5 over 5. Everybody good on where that came from? Okay. So that goes right here. Plus or minus 2i square root of 5 over 5. And last step. Huh? Yeah, for sure. Add 1. Both sides. So x equals 1 plus or minus 2i square root of 5 over 5. And that is it. Don't do anything else. A positive what? Say what? Because you can't have a square root in a denominator.
Oh, I knew it.
So I'm multiplying it times 1 to get rid of the square root in the denominator. And then that square root of 4 just becomes 2. So that's where that comes from. All right. So tomorrow, y'all are going to be doing the homework in class. So it'll be class practice. That is page 211 and 212. Number 1 through 8, 13 through 21, 29, 33, and 41. We did that in class yesterday. We did that in class yesterday.
Great. But they're not very good.
They're in your final grade. No, don't worry about doing it tonight. Unless you just want to get started and have more of a free day in class tomorrow. That's up to y'all. But yeah, that'll be it. And then tomorrow we'll do the homework.